There are reactions that not only go forward, but it also goes in reverse. And these types of reactions are denoted with a double arrow. In an equilibrium, what's happening is that the products and the reactants are going back and forth between each other. So in an equilibrium, the rate of the reaction going forward is the same as the rate of reaction going in reverse. So what does that mean? That the amount of products are being made is the same rate at which the products are being converted back to reactants. That doesn't mean that the concentration of the reactants and the products is the same. It means that the rate at which they're formed is the same. So there's no change in concentration when an equation is at equilibrium, because they're both going back and forth at the same time. Therefore, in equilibrium reactions do not go to completion. There will always be some measurable amount of reactants and products still remaining. Chatelier's principle says that if there's a stress, meaning addition of heat or the addition of a product or addition of reactants, the system will respond by altering the composition in such a way to minimize the stress. In this example here, if we add ammonia to the reaction mixture, then in order to maintain that equilibrium of reactants and products converting at the same time, at the same rate, then ammonium needs to convert into the reactants, go back to equilibrium. So how does exothermic and endothermic reactions play a part in equilibrium? So here we have an exothermic reaction, and we know that because the change in enthalpy is negative, and therefore energy is released. And so if we add heat to the reaction, then we treat that as a product because energy is being produced as it's released. So if you think of it that way, then the more products you have, then the equilibrium will shift to the left, making more products. Which way will the reaction proceed to restore the equilibrium if heat is removed? So pause the video, think about this. Well, remember that here the heat is a product because the energy is being released. So you treat it as a product, and since you're removing heat, then the equilibrium will proceed to the right towards the products to restore equilibrium. As a result, the amount of reactants decreases and the amount of products increase. So how does the catalyst play a role in equilibrium? The purpose of the catalyst is to take a different route to get from reactants to products, and as a result, the activation energy, the requirement to initiate the reaction, is lowered. So that just means that the rate of the forward reaction and the rate of the reverse are increased at the same time. So equilibrium is reached faster.